you need to understand the properties associated with logs and then the laws associated with logarithm. The first property of logarithm is the addition property, which says that if you have, say, log base a of, say, x adding to log base a of, say, y, you can see that they have the same base, so we'll factor the base out, so log base a out, then the addition turns to multiplication, multiply the numbers x, y. So this is the first property, addition of log. They have the second one. You have, say, log x minus, say, log base a of y, the same base, subtraction turns to division, x over y. The third log, saying that you have n log, base a of x to the power, say, n. This expression is the same as n log base a of x. So these are the three properties associated with logarithm. Then we have the laws of log. The first law is saying that if you have log of a number to the same base, the answer is 1. So assuming I have log base 2, log base 2 of 2, the answer is 1. So log of a number to the same base is 1. The last property is that log base a of 1. So log of 1 to any base is 0. So log 1 base 10 is 0. Log 1 base 5 is 0. And an additional property that we look at is the change of bases. When you have a log, you say in base a, and want to change it to, say, base 10, the procedure to go through. So we'll look at that one too. But today's topic is under log table. So we have an expression here. We are asked to use log table to evaluate this expression. We have 0.082 multiplying 3000 over square root of 0.0023. We have to use log table to solve for this. As you can see, this is multiplication, this is multiplying that. It means it came from the first property, which says that when you have two logarithm values adding with the same base, factorize the log out, then you multiply the numbers. For example, if I have, say, log base 2 of 3 adding to log base 2 of 5, the log to the same base out, log base 2 is out, then 3 will multiply 5, 5, 3, 15, just like that for the addition property. Then the subtraction property changes to division. Okay, so now let's look at our log table. For a log table, if you are asked to use log table to solve for question under logarithm, you need a table which will consist of the number and then your log. Okay, so the first number here, we have 0.082 as our first number. So 0.082. Now, to use log table to find the number 0.082, we have two terms that we use. We have the x-sticks or the characteristics, and then what we call the Mantissa. So the characteristics and then the Mantissa. So first, you need to write the number in standard form. So after writing the number in standard form, so standard form say a times 10 to the power n. The number here, the exponent, is what we call the characteristics. And then the logarithm of this number here, the log of that is what we call the Mantissa. So you write your x6 first before your Mantissa. So first, let's look at our number here. In the standard form, we move 1, 2. So 8.2, the number here, we move 8.2 times 10 to the power minus 2. So the minus 2 here is our x6. That is the characteristic. So analog table, the negative is normally written on top this way. So negative 2 against log of this, the 8.2. So log of 8.2 will give you the Mantissa. So log of 8.2 will give you 0.9138. So it will be attached to this. So 9138. But this is log of 0.082, negative 2.9138. So first, write it in the standard form. The exponent becomes your characteristics. The log of the number here, the a, becomes your Mantissa. Okay. The next number there is 3000. Write 3000 in the standard form. So move 1, 2, 3. So it will be 3.0 times 10 to the power 3. So 3 becomes your s6. So 3, then log of 3. Log of 3 will give us 0.447. So 0.4771. And the last one is, the number is 0.0023. In the standard form, we move 1, 2, 3. So we are going to get 2.3 times 10 to the power negative 3. So your s-stick, your characteristic is negative 3. Then you put log of the number, log of 2.3, get 0.3617. Okay. So we are done with the number and then the log. So these are the logs. 0.08 to give you negative 2.9138. 3000 gave you 3.4771. This gave you this. Okay. So from the properties of log, multiplication becomes addition. Meaning we are going to add this and that, the logs, this plus this. Division from the property becomes subtraction. As you can see, the denominator, it was having a root on it. And this is the same as the root of this number is the same as that number to the power half. So from the third property, where we learned that if you have n log base a of x, is the same as log base a of x to the power n. Okay. So the root of this number is the same as this number to the power half. And as you can see, the half is representing the number n. So the exponent will kind of multiply the number, as you can see, as a coefficient. So meaning when it comes to the table, this value here, we have an exponent on it, which is half. And the half from the properties of log should multiply the number. So the half will be multiplying this. So you have 1/2 multiplying negative 3.3617, as you can see here. Okay. So this is the same as negative 3.3617 divided by 2. There's it. Okay. Before we come to this, let's first look at the addition property here. So the addition there, we have .082 multiplying 3000. So multiplication tends to addition. This is this number negative 2.9138. So we have negative 2.9138. So let me call this equation 1, expression 1, then expression 2. So we are adding expression 1 plus expression number 2. So adding this to that from the multiplication property. So let's add it. So this will give us 9, 10, remainder 1, 8, 9, 9 plus 4, we'll get 13, remainder 1. So the 1 will come here, already owing negative 2, so making it negative 1 plus 3, so giving us positive 2. Okay, let's move on again. Let's go over 9, 10, remainder 1, 8 plus 1, 9, 13, remainder 1, plus 3, 4, minus 2, positive 2. Okay. So we have here this expression. The half multiplying this, which is the same as 1 times this, giving us that all over 2, so divided by 2. You don't divide this on the calculator. So when you had an expression, when you get something like this and you are dividing, first you need to look for a common factor that 2 will divide without a remainder. 2 dividing the least number that 2 will divide without a remainder. It means that this expression can be written as 4 plus, so 2 dividing this expression minus 3, to make sure that the 2 go into this without a remainder. I can factors of 2, so 2, 4, 6, 8, so plus 1.3617 like this, then I'll divide it by 2. So 2 divide this, giving minus 2 plus, then 2 divide 1.3617. 1.3617 divided by 2 will give me 0.6809. So I'll get minus 2.6809. Okay. So as you can see, the denominator here is giving minus 2.6809, which the top from the property was dividing the bottom, that is the numerator dividing the denominator, and from the property division tends to subtraction, and there is the numerator after adding, and this is the denominator after finding the expression. So it means that it is the numerator from the property, addition, subtraction property tends to division, so the numerator minus the denominator. So I have this expression here. Okay, let me come here. I have 2.3909 minus the bottom minus 2.6809. So 9 minus 9, 0, 0, 1. 6 minus 3, so borrow 1 from here, making it 13. Then 13 minus 6, 4 plus 3, 7. Points here remain with 1. So I have 1 minus 2, so making it plus. So positive 3, as in this. So our final answer, meaning that we have log base 10 of x equal to this 3.7100. So if you want to find x, then x becomes equal to 10 to the power 3.7100. So 10 to the power, that is what we call the antilog. So 10 to the power 3.7100 give us 5128.61. Okay, so that's the final answer for the expression there using log table. So first you need to write your values in standard form. The index is your characteristic, then the number, the log of that number will become your mantissa. Then after doing that, you apply the properties of log using the addition and then subtraction properties. The addition, multiplication changes to addition, the division changes to subtraction. Always know the third property. When you have a root on it, either square, cubic root, fourth root, make sure that that root will be the index of that number, and the number, as you can see, will kind of multiply, the index will kind of multiply the number, and always you divide it using the third property. But under your division, always make sure that when you are dividing, you know, as we did it here, the value here was minus 3.3617. It was like this, minus 3.3617, where we are dividing it by 2. But you can see that 2 cannot divide this without a remainder. So first, you need to look for the factors of 2. So this is the same as this. We've not changed anything. We just want the 2 to divide the value without a remainder. That's why I looked for the factors of 2, where I had minus 4. Then I asked myself, what value should I add to this without changing the value 3.3617? So adding 1.3617 to the expression minus 4 will give me back this. So after dividing 2 by this without a remainder, I had this. Before this we divide by that, then you add, you get your final answer. And after, you take your antilog to get the answer for the expression. So that's an example under log table. First, you need to write the expressions in standard form. Index becomes your characteristics, then the number, the log of that number becomes your mantissa. Thank you, and make sure that you continue to watch Engineering Solutions, the only solutions with what? A Z. Subscribe to the channel. Thank you.